Hello friends, in this video we are going to create our own custom exception, and the exception falls under checked exception. We already saw the Java's unchecked exception. In the previous demos we looked at arithmetic exception, array index out of bound exception, and string index out of bound exception. So those are all kind of unchecked exception. That's why the Java compiler doesn't force us to handle those exceptions. So we voluntarily kept try and catch, and we explored those unchecked exceptions. Now we will create our own checked exception and study how Java compiler checks this checked exception and forces the calling code to handle it. So when a method throws a checked exception, the calling code of that method should handle that exception, or it can delegate that to its caller. So you will get more picture when we are proceeding with this video. Here we will create a custom exception for the product class. So the custom exception falls under checked exception, right? So that means we are going to create a product class, then we will create a custom exception, then we will throw that custom exception from this product class. Then whoever is using this product class will handle our custom exception. We will see all those stuff in this video demo. We will also learn how the user of the product class handle our custom exception. Yeah, as already told, that's also part of this video. Okay, let us start. And here you will also study about throw and throws keyword. First we create a product class with 3 members, and here is our product class that will be kept inside the com.product package. So it has 3 members: prod ID, product name, and stock in hand. The constructor initializes the stack to 0, so that's a default. Here is the constructor, and even though we initialize the stock in hand as a 0, we expect the product ID and name from the user. So whoever is constructing our product class will supply the product ID as well as the name for the product. The toString override will provide a formatted information of our product. So here the toString tells the state of our product, and the state is formatted here. First we print a product ID, then product name. We also tell how many stock we are holding. Next we provide 3 methods for handling the stock of the product. So first we have a method called purchase that will increase our stock in hand. Then we have a method called take stack, and that will reduce our stock in hand. We also have a sell method, and we make a call to that take stack through the sell method. So the user of our product class will sell the quantity, but the inventory maintenance here is kept as a private, the take stack. We should have done that for a purchase also, but here for demo purpose I just kept take stack as private. So then in the Java main method we create the instance of the product class. Here in this example we are giving an ID as 101, and we are naming our product as a pen. Then we purchase 10 pens, so the stock in hand will be 10 at this stage. first we sell, okay, before that we will look at the code. Alright, first we sell 7 product. So the stock in hand at snippet 3 is 3. So we are attempting to sell 7 pen. So since we have a sufficient pen in hand, we can sell 7 pens. So after this sales, we have 3 in our stack. The second sell attempt is a 5. So now the stack is not sufficient. So here at this moment the stack will go in minus, and you will be seeing that in the print line statement that is following the sale of this sales of this 5 product, mean the 5 pen. Alright, so at this stage we will do a test run in Eclipse. After that we will proceed with the custom exception. Okay, first we will create a new Java project and we will name this as a custom exception demo, and that's all. Next, what we will do, we will create a package and we will name this package as com.products. Then we will add our class product. Alright, so we have the class called product. Let us look at that. So we have a class called product. Then the first thing what we need to do is we have to add 3 members. So we have 3 private members. Then we will create a constructor. So the constructor is taking into argument, then it is initializing the stock in hand as 0. After that, we provide a override for toString method. So it will print our product class in a formatted way. That means it will tell what is the product ID followed by product name. Then within square bracket it will tell the stock in hand in terms of a number. Alright. Next we will provide the inventory handling methods. So here is our 3 method: purchase, take stack, then sell. If you see, the take stack is private and user cannot access this take stack directly. They can access a sell and a purchase. The sell will in turn make a call to the private member take stack. Alright, now here is our main entry. Before that we need to create a class for it. We'll create a new class and we'll say this is as a main entry, and we need a public static void main. Alright, now we will make a test run here and we will see what is the output. So first what happens, we are purchasing a 10 product. In the previous line we constructed a product. That means now we have a pen product. Then we purchased it. So 10 quantity we purchased. So when we do print len and when we pass that, when we pass the pen object, it will make a call to our toString and it will provide a formatted output. So it says that the ID of the product is 101 because during the construction time we gave that. Then the product name is pen, that also we supplied during the construction time. So during the construction time the stock in hand is 0. Since we purchased a 10 product, the stock in hand now shows a 10. Now I am making a sales. So I am selling a 7 pen. So now that call will reduce the stock in hand, and when we print that pen, we will get the stock in hand is 3 because 7 sold and 3 remains in the inventory. Now when we try to sell 5, our current code accepts that and it says that stock in hand is -2, and after that we are selling 2 more pen and it states stock in hand as 4. So this is a error condition. So here, as far as Java is concerned, there is nothing wrong here, but as a business logic we should not allow selling the pen and keeping our stock in hand in negative numbers. That means when there is no stack, we cannot sell 5. The stack is only 3. The stock is only 3 and we are selling 5 pen. So we should not allow this. So this is the business logic error. So we can simply put if condition, but how do we force our user calling the method when there is no stack? So if it doesn't provide exception, we are depending on the caller of this product to handle it themselves. That means they have to maintain their own inventory. They should know what is the stock in hand. When stock in hand is lesser than the claimed quantity, then they should not make a call at all. So it will go like this. So if we handle the exception, even if a user performs this kind of action mistakenly, we will throw the exception and the caller will get to know that they are claiming when there is a less stack. Alright, now we will go and implement our custom exception. So okay, now we will go back to our PowerPoint slide. We will stop the Eclipse demo here. The custom exception, out of stock exception. So that is what we are going to implement now. Here we derive our custom exception from Java's exception class. You don't need to worry about all this code, so the Eclipse will generate this code for that. What we can note here is the class OutOfStockException is derived from the class exception. Exception is supplied by the Java framework, and we are deriving our class OutOfStockException from the existing exception class. Since we are deriving it from the exception class, our class OutOfStockException falls under the checked exception category. So in the previous video we already saw the Java exception handling hierarchy. I can say the error handling or error or exception handling hierarchy. So any class derived from exception is checked exception. That means here we are creating a checked exception. You can also note the usage of a super keyword. That means we are making call to the superclass constructor. Actually, if you see here, we are not writing any piece of code. All we did is we just created a new class, the new exception type, and that exception is derived from the existing exception class. Since we derived out of exception, our custom exception falls under checked exception. So we already explained that. Alright. So our custom exception is now ready. Let us revisit the product class. So now you will come to know the usage of throws as well as throw keyword and how we will use that in Java. In the TakeStack method, we raise the exception using the Java's keyword throw. So previously we have a stack in hand equal to stack in hand minus quantity. But now before reducing our stack, we are first checking that the claimed quantity can be fulfilled by our stack in hand. So if claimed quantity is greater than the stack in hand, then we will throw an exception. Here, if you see, after this if condition, we are making use of the throw keyword. Then we are constructing the exception object. Here we are constructing our own exception, out of stack exception. Then we are passing a string message to it. So in the previous slide you saw there are a variety of constructor. One constructor will take a string as a parameter. So here we are actually giving the message why this exception is thrown. So we are saying that stack insufficient. So that's why we are throwing this custom exception. The raised exception is our own exception. That means this is our custom exception which we created in the previous slide. Since the method raises the exception, we mark this method Java's throws keyword followed by the exception it throws. If you look at here in the top, we are placing the throws keyword, then we are marking that with the out of stack exception. If your method throws multiple exception, we can place comma separated list after throws keyword. So we can actually place multiple exception after the throws keyword. That means if you see 3 exception after this throws keyword, then inside the possibility, somewhere in the code, this exception will be raised. So that's what it means. It also means that the method is not handling the exception. It is either throwing the exception or some of the called function in this method is throwing an exception and this method is not handling that. Alright, so here in our case we are not handling any exception, we are throwing the exception because this is the exception source, and we mark this method as method with the throws keyword. So once we throw an exception from this TakeStack method, Java compiler will throw an error in the calling method. So here in the cell method, we are calling the TakeStack. If there are several methods, all those methods will throw an error now. That means the compiler will throw an error for all those methods. So one should revisit those methods and they have to handle the exception. Previously, TakeStack doesn't throw any exception. So once we use that throw keyword and start throwing the out of stack exception, the calling code, here the cell is the calling code, the Java compiler will check that calling code and throws an error stating that the exception type is a checked exception, so the user should handle that. So if you haven't derived our out-of-stack exception from the runtime exception, then Java compiler won't throw any error. But since the exception here is checked exception, the compiler will force you to add this try catch block, or you can mark this method with a throws keyword. We will see that when we go to the Eclipse demo. In the settle method, we handle our custom checked exception, and you are seeing that there is a try catch block, and in the catch block we are handling the out of stack exception. Then we are printing a message using the e.getMessage method. Alright, now let us go to Eclipse and test this. So okay, so we already did a test run, and we also saw that how our stack goes in a negative number. Now we will implement our custom exception. So we don't need to copy paste this because Eclipse will generate all this boilerplate code for us. So we will go to Eclipse, and then we will create a new class, and the class name is OutOfStockException. So we don't want to derive it from java.lang object. We will derive it from exception class. So java.lang.exception. So this is our base class, and we need a constructor from the superclass, and that's all. We will click finish. So if you see whatever we had in the PowerPoint slide, that get created here. Alright, now our checked exception is ready. This is from our previous run. We will clear that. Next, modify takeStack function to throw our custom exception. So this is the line we are going to add. Okay, we will copy the entire method for simplicity. So here is our takeStack method, and we are going to modify it. Previously, if you saw, only this expression is there. Now we are going to add, this is the previous one, now we added these two. So what we are saying, now we are saying if quantity exceeds the stack in hand, throw a new exception. So here we are throwing a new exception, and the exception message is a stack insufficient. Alright, I haven't saved it yet. You can see a star mark here. Once I save it, I can see the problem statement, unhandled exception type, out of stack exception. So this is what called checked exception. Now I can surround this statement with the try catch block. So that is the next step. Java compiler forces this change. So you saw that there is an error. So that's how we end up placing a try catch statement. So I'll just take only the catch statement. Instead of printing this stack trace, I just want to print the message from the exception. So the message will actually print insufficient stack, the stack insufficient. If I save it, that error is gone. That means we handled this. Okay, so delegate all the stuff we will do later. Now we will test our application, our example. So there is no change here, and we will test how our class is now behaving. So now our product class handles the exception, and the exception is created by us. It's our custom exception. Now the stack in hand is 10. We are selling 7 pen. Stack in hand is 3. Now we are attempting to sell 5 pen, and we get the exception, stack insufficient. It means quantity in hand is 3. We are climbing more than that, so that's why it printed stack insufficient. So now the execution resumes because stack in hand is 3, and this time the sales is for 2 pen only. So our in hand stack can supply that quantity, so we doesn't get error this time, and stack in hand goes 1. If you see here, even though we got an exception here, the user of our application can proceed with the remaining statement. That means they can still able to dispense 2 pen to the customer. 2 pen to this method call, because here it is not an error condition. Since stack in hand is 3, 2 is absolutely valid, so we are still executing that statement, and we are still maintaining our inventory, and that inventory now goes to 1. So we are not halting the program because of this one single mistake. These cells are independent. There are 3 cells. So if we terminated our execution here, then this statement is actually valid, and we will not get a chance of executing it. So that's the use of handling the exception. Now we will go to the alternate. Here, if you see, we are handling the exception, right? There is one more alternate. So now I am not handling the exception. When I click here, the Java gave us 2 options. One is surround with a try catch, or you can even delegate this with a throws keyword. So previously we saw throws keyword. Why? Because we are throwing the exception. Here we are not throwing the exception. We are making call to some function, but that called function will throw the exception. So in cells perspective, in the cell method perspective, we have 2 options. One is we can handle the exception because the take stack throws the exception, or if you don't want to throw the exception, we can say that the body of this cell method throws the exception. Body of the cell method, in the sense it is not throwing directly here, the called method is throwing. So we are once again stating throws out of stack exception. That means the caller of this cell method is now responsible to handle this out of stack exception. And if you see, the main method is already having that error. Since it is calling this cell method, we are getting this out of stack exception in the main method. Now we will come to know that how exception bubbling is happening, right? And so if you won't handle here, this exception will bubble out to its caller. Now it is caller's responsibility to handle this exception. Since it is a checked exception, the method cell escaped saying throws out of stack exception. Escaped in the sense it looks funny, but what it says is I do not want to handle this exception. It will be meaningful if caller of cell method handles that exception. That's why it marks that with a throws keyword. Here in our case it is just a demo and we are exploring. That's why I just kept throws keyword. In some cases, we may delegate it to the caller instead of handling it inside. So that's why we have two options. So if it is valid to handle inside this method itself, we can handle it with the try catch. Or if we feel the caller is the right place to handle that exception, then we can mark our method with the throws keyword. Now we can go and surround with the try catch. If you see, I'm not placing all these three methods inside a single try catch. We can even do that, but it will be because we want to proceed further. If the sales of one particular statement failed, we don't want to fail all other statements. We want to still execute. Why? Because we can dispense the other quantity if it is valid. So that's why we are placing multiple try catch. So previously we printed the message, right? This time we will leave it to the default. This time it will print the stack trace where the exception is originated and where it gets handled. So you will see that information. So if such an exception is raised in production, and I mean in the client environment, they will give this stack trace information to the developer so that they will come to know where exactly the exception is thrown and where it got handled. Now if I save this, all error will go away and we can still execute this. So now it will throw an exception and it will get handled here itself. So here it is printing the stack trace in red color, but we can still proceed. And now it shows that stock in hand is 1. Alright, so if you look at, we looked at two examples. One is handling it inside the stack in hand itself, and stack in hand delegating it to the caller. So, and you can see the pain here, they have to call it in multiple places. So the best place to handle this exception is inside the product class itself. Alright, now alright, that's all in this demo. So you can experiment placing a throws keyword here in the main itself. You know what happens if you place here, we know that the main is the starting point. So if you say throws here, then to whom we are delegating it. Main is the entry point. that means we may be delegating it to the JVM itself, and if we are giving it to JVM, then JVM will treat this as a unhandled exception and it will terminate the execution flow. So I am leaving it for your exploration, and you can try that if you need, but that's not a good practice because it's the main entry and here the exception needs to be handled. We cannot delegate it to the JVM. That's all in this video demo. Alright, thanks for watching. Bye.